So today we're going to go through what a Latin square design is with some given examples, so let's jump right into it. In this first slide, I have an example of a very basic structure of what Latin square design looks like. A Latin square design is an n by n array containing different symbols such as letters, numbers, colors, etc., each only occurring once in every row and column. There isn't a limit to how large these arrays can be, so they can range from 1 to 5, 1 to 10, 1 to 100, 1 to a million, and so on. The example I've given though is a 6 by 6 Latin square design. As you can see in the table, each letter only occurs once in each row and column without having any sort of overlap. These designs are used to both control or eliminate two sources of nuisance variables. Latin squares are used mainly for when researchers want to visualize the data in an experiment by placing it in an array structured like the Latin square design. So for the second slide, I have an example of how a Latin square could be used in an experiment. A courier company wants to decide between 5 different brands of cars for its next purchase. They choose 5 different drivers and record the average cost per mile in a 5-week period. Each week a driver is assigned a car at random using Latin square design and randomization. We can set up this proper table. As labeled in the key, you can see the letters are the car type and the numbers being the mileage recorded through each vehicle. This Latin square design lets you organize this data effectively and be able to find the average mileage of each vehicle corresponding to the person driving it that week. And then in the end, you'd be able to find out which is the most efficient different brand of car you would want to choose. In this last slide, I have an example that's very similar to the slide before, but as you can see, the layout of this Latin square design is a little bit different. I did this to show that they don't all have to look the same, and Latin square designs can have different looking layouts. This Latin square shows 5 different computers with different operating systems and testing the number of bugs or errors that each have when running a certain program. Again, using this Latin square design, we can organize this data through randomization, and we can find the average and factor out the outliers to find the most successful computer operating system combination.